Welcome to Lesson 1 on the periodic table. In front of you right now, you should have your Lesson 1 periodic table note sheet. Throughout the course of this video, I will be filling in the blanks that you need to write on your note sheet. At certain times throughout the video, I will have hidden talking points, which you will need to write either on the sides of your note sheet or on the bottom or possibly on the back side. I will tell you at that time. Okay, so we're going to start from the top where it says organizing the periodic table. First we need to know what periodic means. And periodic means repeated in a pattern. So basically this is just telling us that when we organize the periodic table, we're looking for that pattern. Mendeleev, whose picture is right here, is a Russian chemist who organized the elements based on their increasing atomic mass. The change in the mass of the elements was said to be periodic, thus creating the periodic table of the elements. In addition to atomic weight, elements were also arranged by chemical properties. This is a picture of Mendeleev's first periodic table. Mendeleev had arranged all the elements he knew, just like this on here, on this table. And from the blank spaces he found, so these are the blank spaces here, here, over here, he was able to predict the properties and mass of elements he had not found. Eventually, these elements were discovered by scientists. Eventually, a man named Henry Moseley came along and arranged the periodic table by atomic number, not by atomic mass. And that's how it's arranged today. And that's just what this picture is showing. You can see that here the atomic number for hydrogen is 1, then goes to helium 2, lithium 3, 4, and so on throughout the entire periodic table. Next we'll move on to the section called the atom and the periodic table. The periodic table is arranged by the properties that elements have in common. Vertical columns, so this vertical column is called a group, and another name for that group is a family. And these are all grouped by their properties. And for your first talking point, somewhere on the left side of your sheet, please write that copper, silver, and gold are all shiny and are good conductors. This is a picture of the atom. Electrons are the negatively charged part of the atom. And they're out here. In a neutral molecule, they equal the number of protons. And those protons are found here in the nucleus. The electrons are located in the electron cloud that surrounds the nucleus. And the nucleus is right here. This is a picture of an atom with energy levels. And now letter C says scientists model different energies of electrons by putting them in energy levels. The electrons in the outer level, so electrons out here, determine the properties of an element. Elements in the same group have the same number of outer electrons. So you should have had outer in that blank. And for your second talking point, to the left on your sheet, please write that elements are stable when the outer energy level is full. Moving on to letter D. Rows on the periodic table are energy levels. There are a total of 7 energy levels. So you see that this would be energy level in row 1, energy level in row 2, 3, 4, 5, 6, and 7. Energy level 1, so this first one right here, can hold 2 electrons. Every energy level after that can hold 8 outer electrons. Any extra electrons are filling an inner energy level. Hydrogen is found here in row 1. It has 1 energy level and 1 outer electron. Helium, second element, has 2 electrons and is stable. Lithium, found right here, starts energy level 2 and has 1 outer electron. The second energy level ends on the other side over here with neon, which has 8 outer electrons and, like helium, is stable. Elements that are in the same group, so remember that's a vertical column, have the same number of outer electrons. Sodium, hydrogen, and lithium, so the group that I circled, all have 1. These electrons are so important in chemical properties that there's a special way to draw them called an electron dot diagram. To do this, what we do is we write the chemical symbol of an element, and then we use dots to represent outer energy level electrons. So for sodium, I would make 1 dot on top here. Electron diagrams are eventually used to show elements bonded to other elements. Finally, to end with letter B, all elements in group 17, that's right here, have 7 electrons in their outer energy level. A common property of these elements is that they combine with elements from group 1 which have 1 electron in their outer energy level. An example of this would be NaCl, or commonly known as table salt. Not all elements will combine with others. Elements in group 18, that's these, that's group 18, have full energy levels, so they will be stable. Alright, the last thing I would like to do, and for our last talking point, we are going to draw the electron dot diagram for each of the row 3 elements. So we'll start with sodium, Na, and it has 1 outer electron. Next is magnesium, and it has 2 outer electrons. Third is aluminum, and it has 1, 2, 3 outer electrons. Fourth is silicon. It has 1, 2, 3, 4 outer electrons. Fifth is phosphorus. Phosphorus has 1, 2, 3, 4, 5 outer electrons. Sixth is sulfur, and sulfur has 1, 2, 3, 4, 5, 6 outer electrons. Then comes chlorine with 7 outer electrons. And last is argon. And if you see, argon has 8 outer electrons, and it has no spots where it doesn't have 2 on the outside, so that makes it stable. And that is going to wrap up lesson 1 on the periodic table.